Today's lesson is 2.3 subtract fractions and decimals. It's very similar to our last lesson, add fractions and decimals. First, it's important to remember that for subtracting rational numbers, we use the same rules for signs as we used for integers. One thing that's important to remember is that if we're subtracting a negative number, it's like adding. For example, if you owed somebody money and I took away that debt by paying it off, it's like giving you money, but it just went to somebody else. So the big important thing to remember, subtracting a negative is adding a positive. So our directions for most of our examples: subtract, write the fractions in simplest form. In problem number 1, we have negative 7 minus 5/7. And in order to subtract fractions, we need to have a common denominator. And first, we have a whole number, negative 7. I'm just going to write it as negative 7 over 1 to start that off as a fraction. And now I need to find the least common denominator between 1 and 7. Well, it's going to be 7. So I need to write negative 7 firsts in terms of sevenths. In order to do that, what we're going to do is multiply top and bottom by 7. Notice that fraction 7/7 has a value of 1, and multiplying by 1 doesn't do anything. What it will do, though, is make it look a little different. 7 times negative 7 is negative 49 over 7 times 1 is 7. And so we have negative 49/7 minus 5/7. And now we can just subtract our numerators because we have a common denominator, and this is going to equal some number of sevenths. And that number is going to be the result of 49 minus 5. And in this case, we start with a negative number, then we're taking more away, so it's going to be a bigger negative number. It's like adding these two together, but our result will be negative. 49 plus 5 is 54. So our result of 5 less than negative 49 is negative 54. Problem number 2, we have some mixed numbers, negative 5 and 9/10 minus 7 and 3/5. First thing I'm going to do is convert these to be improper fractions. 10 times negative 5 is 50, plus 9 is going to be 59. So this is negative 59/10 minus 7 and 3/5. To convert this into improper fraction, we do 5 times 7 plus 3. 5 times 7 is 35, plus 3 makes 38 over 5. But we don't have a common denominator. So we need to make a common denominator. The least common denominator between 10 and 5 is going to be 10, because I can get a 5 to be a 10 simply by multiplying by 2. Now I have to multiply the numerator and denominator by 2, so that in essence I'm multiplying by the number 1 and not really changing anything's value. Finally, I get this problem, negative 59/10 minus 76/10. 76 being the result of 38 times 2, and 10 obviously 5 times 2. It's negative 59 minus 76. The result will be out of over 10. And negative 59 minus 76, I don't know that one off the top of my head. So what I'm going to do to find it, just over here in my margin, I'm going to add 59 and 76. Because I have a negative minus a negative, it's going to be at a bigger negative number, and we can find that by adding. 9 plus 6 is 15. Carry the 1. 1 plus 5 plus 7 is 6 plus 7, or 13. And our result for 59 plus 76 is 135. So our result of subtraction is negative 135/10. Unfortunately, I can't leave my answer in this form because I always reduce my fractions. Negative 135 and 10 have a common factor, and that is 5. So I'm going to divide the numerator and denominator by 5 to get a reduced answer. 5 goes in 120 times and 35 7 times. So I get 27. And on the denominator, 10 divided by 5 is 2. Our result is still negative, and my final answer in reduced form is negative 27 halves. Notice our directions. Say write fractions in simplest form. As long as I simplify and take out that common factor of 5, I'm okay. Often students think they have to write them as a mixed number, and that's just not true. I have a saying about improper fractions. The only thing that's improper about an improper fraction is its name. There's really nothing wrong with the answer negative 27 halves. However, if you prefer, you can divide and write it as negative 13 and 1/2. Either one is acceptable. Problem number 3, we have negative 4 1/4 minus 6 3/8. This is the same pattern as the problems before. Why don't you pause the video, try this one on your own, and press play when you're ready. I'm going to do my work very quickly here. First, I'll write it as improper fraction. 4 times 4 is 16. My plus 1 is 17. So I have negative 17 fourths minus 51 eighths. To get a common denominator, I'll multiply 17 fourths top and bottom by 2. And I get 34 eighths. It's still negative. Minus 51 eighths. Negative 34 minus 51 makes a larger negative 85 eighths. And there's no common factor between 85 and 8. So our reduced answer is negative 85 eighths. Our next 3 problems are on decimals. So I have negative 13 minus 5.9. Anytime we're subtracting a number from a negative, we know it's going to make a bigger negative number. I'm going to take 13 and add 5.9. It's important that when we're adding, we line up our decimal places. I'll put in that extra 0 for the 13. But I know that my result is going to be negative. So I'm just going to write that negative down in front right away. And now I can add these numbers. 0 plus 9, 3 plus 5, and 1 plus 0. My result of negative 13 minus 5.9 is negative 8.9. Number 5, 14.6 minus negative 9.2. Minusing a negative, those double negatives cancel. And it becomes just one big plus sign. So our answer is going to be the result of 14.6 plus 9.2, and it's going to be positive result. So we'll add 6 plus 2 makes 8. Let's bring down our decimal point. 4 plus 9 is 13, and carry the 1. 1 plus 1 is 2. Our result of 14.6 minus negative 9.2 is positive 23.8. Number 6, we have negative 7.4 minus 10.8. Again, we're subtracting a number from a negative. It will be a larger negative number. The result will be of 7.4 plus 10.6. But our answer will be negative, so I'm just going to write that negative sign down right from the beginning. 4 plus 6 is 10. Carry the 1. 1 plus 7 plus 0 is 8. And then we still have our 1. And our result is negative 18.0, or just negative 18. Our final problem is a word problem. And this is just one of many, many, many examples of when we might use adding or subtracting rational numbers in real life. This problem says in the water, the bottom of a boat is 2.1 feet below the surface, and the top of the boat is 8.7 feet above it. Towed on a trailer, the bottom of the boat is 1.3 feet above the ground. Can the boat and trailer pass under this bridge? And our bridge has a clearance of 11 foot 8 inches. So it's going to take a couple steps in this problem. First thing we want to do is find the total height of the boat. And I'm going to do that by drawing a little picture. It's going to be very sketchy sketch. And all I need is to have a boat. And we know that boat is going to be in the water. Let me add a little more to the boat. There we go. That looks better. And I'm going to put a number line here on the side of the boat where the water level is 0. We know the bottom of the boat is 2.1 feet below the surface. So this is going to be not just 2.1, but it's below negative 2.1 feet. And the top of the boat is 8.7 feet above it. And we want to find the difference between the top and the bottom. Guess what operation that word difference leads us to? Subtract. We're going to do 8.7 minus negative 2.1. And in this case, I think it makes it pretty obvious. We're taking the distance from 0 to 8.7 and adding the distance from 0 to negative 2.1. And this subtraction of a negative number really does make sense as addition. And we get, as a result, the boat is 10.8 feet tall. Now, to answer this question, it tells us that the bottom of the boat, when it's on a trailer, is 1.3 feet above the ground. Can the boat and trailer pass under the ground? So we need to do one more addition problem. We're going to take the height of the boat, 10.8, and we need to add to it that extra 1.3 feet between the bottom of the boat and the ground. And we find that the total height from the ground to the top of the boat when it's on the trailer is going to be 12.1 feet. So to answer our question, can the boat and trailer pass under the bridge? Well, the bridge is 11 feet 8 inches of clearance, so we can definitely say no, that would bust our boat if we drove through. Don't do it. And that's why subtracting negative rational numbers is an important skill. We just saved this boater from the catastrophe of driving his boat through the tunnel.